When we look at Mars today, the red planet, we see this cold, barren world. But what if I told you it wasn't always like that? Billions of years ago, Mars was a totally different place, and it was protected by something powerful, something it's now lost, an invisible shield. So what happened? Where did it go? Let's dig into this incredible planetary mystery.
Okay, so let's just paint a picture here. We're talking about ancient Mars, a world that all the evidence suggests was warmer, probably wetter, and wrapped in a thick atmosphere. I mean, a place that could have had rivers and maybe even oceans. Now flash forward to today and, well, it's a frozen desert. Its atmosphere is barely there, less than 1% of Earth's. The change is just breathtaking.
So this transformation, from a world with real potential for life to a hostile wasteland, this is one of the absolute biggest questions in planetary science. What in the cosmos could cause such a complete and total climate collapse?
To start unraveling this, we've got to look next door. We need to compare Mars to its much, much luckier sibling, our home, planet Earth. Think about it. Earth is just bursting with life, right? And a huge reason for that is our planet's powerful magnetic field. It's this invisible force field that wraps around the globe, protecting us from all sorts of nasty solar radiation. Mars, on the other hand, it's basically standing out in a cosmic storm with no umbrella. That shield, or lack thereof, is the critical difference. It's the fork in the road where these two worlds went down completely separate paths.
But here's where the plot really thickens. Mars wasn't always so defenseless. In fact, scientists have found what you could call the ghost of its long-lost shield.
That's right, the evidence is undeniable. Mars once had a powerful magnetic field, a lot like Earth's. So the question isn't just why doesn't Mars have a shield? The real mystery is why did it lose it? So, how do we know this? Well, the smoking gun came from NASA's Mars Global Surveyor. It found these huge patches of the Martian crust, especially in the southern highlands, that are strongly magnetized. It's like a fossilized fingerprint. Billions of years ago, as lava cooled into rock, it literally froze a record of the planet's magnetic field at that exact moment. Finding these magnetic fossils is definitive proof that Mars once had a powerful dynamo engine churning away deep in its core.
Which brings us right to the heart of it. If Mars had the whole setup, if it built this planetary shield, what on Earth went so wrong that it just switched off?
Okay, to solve this, we first need to understand the recipe. What exactly does it take to cook up one of these planetary force fields in the first place?
The process is called a planetary dynamo, and you can just think of it as a gigantic natural engine running in the heart of a planet. But like any engine, it needs some very specific parts and fuel to keep it going.
It really boils down to three key ingredients. First, you need a liquid core made of something that can conduct electricity. Molten iron is perfect. Second, you need enough internal heat to get that liquid churning, convecting, kind of like water boiling in a pot. And third, you need the planet to spin fast enough to organize all that churning liquid into a powerful, stable magnetic field. Earth has all three, and our dynamo is still going strong.
Now Mars had all three of those ingredients too, for a while at least, but one of them failed. And all the evidence points to one prime suspect. The planet just got cold way too fast.
And the reason why is actually pretty simple. It's all about size. Mars is just a much smaller planet than Earth. We're talking about half the radius and way, way less mass. And in the life of a planet, it turns out size is everything.
I mean, just to put that in perspective for you, Mars is only about 11% of Earth's mass. It's a cosmic lightweight. And being that small had some really profound and ultimately fatal consequences for keeping its internal heat.
You see, here's the crucial principle. Smaller planets cool off faster. Think of it like this. A tiny little espresso shot is going to get cold way faster than a giant thermos full of coffee, right? That's because the small cup has more surface area compared to its volume. Well, Mars was that espresso shot. It just radiated its primordial heat out into space far more quickly than the bigger Earth could. So the conclusion is pretty much inescapable. Mars lost its magnetic shield because it was just too small to hang on to its internal heat. As the planet cooled, that churning convection in its core slowed down, and then it just stopped. The engine ran out of fuel. The dynamo sputtered out and died.
And once that shield was gone, the planet was left totally defenseless. Its atmosphere was, well, a sitting duck, and it started to just bleed away into space.
So meet the villain of this chapter, the solar wind. This is a constant, relentless stream of charged particles blasting out from the sun. Earth's magnetic shield just bats it away. But with no shield, the solar wind slammed directly into the Martian atmosphere, literally sandblasting it away, molecule by molecule, over millions of years.
And this timeline just shows how incredibly fast it all fell apart. Around 4.2 billion years ago, the dynamo was humming along. Mars is warmer. But by 3.9 billion years ago, bam, it's gone. Almost immediately, the solar wind starts its attack, and in just a few 100 million years, which is a blink of an eye in cosmic time, so much atmosphere was gone that liquid water just couldn't exist on the surface anymore. The planet's entire climate just collapsed.
So, what can we learn from this planetary tragedy? Well, Mars gives us some really profound lessons about what it takes for a world to not only become habitable, but to stay that way.
It really all comes back to that magnetic shield. It was the linchpin. It was the bodyguard for the atmosphere which kept the planet warm enough for liquid water. When that shield failed, the whole house of cards came tumbling down, turning what was a really promising young world into the frozen desert we see today.
When you think about it, the story of Mars is really a cosmic cautionary tale. It's a reminder that a planet's ability to host life isn't some permanent feature. It's this incredibly delicate dance of conditions, and what's happening deep inside a planet is just as important as where it sits in its solar system.
And this all leads to a final, really big thought. As we're out there searching for life on planets orbiting other stars, we always talk about finding them in the habitable zone, not too hot, not too cold. But the story of Mars teaches us to ask an even deeper question. Does that planet have a shield? Because finding a world in the right spot isn't enough. It also needs the internal strength to protect itself. And that shield, it might just be the ultimate gatekeeper for life anywhere in the universe.